Hey guys, we're back. We're talking about section 1.5B, even and odd polynomials. Let's jump into it. So even functions are symmetrical over the y-axis, okay? And we see that in these following graphs where every point will flip over the y-axis and line up to another point on here. So we can see that here where here we also can see it. I can see this flips over this way and so on. Here, I can see that this will flip over completely this way, symmetrical here. In geometry, we said, hey, x comma y will map to negative x comma negative, or excuse me, positive y. Okay, so the x changed, but the y doesn't change. Odd functions are symmetrical over the origin, which is the point 0, 0. So let's explain what that looks like. So that means every point on this graph will flip through the origin to the other side. Same thing here. This will go through the origin to this point. This will go directly through the origin to the other point, and so on. And that's when we call this in geometry x comma y will map to negative x comma negative y. So let's look at further. An even function is graphically symmetric over the line x equals 0, which is also called the y-axis, right? So if I wanted to recreate the rest of this, so I know here it's on the y-axis, so that touches that point. This point here, we know if I'm going to flip it over the y-axis, it's going to be right here, so I can connect these two. Here we can call this, I don't know, what is that, 1, 2, positive 3, positive 4, which means I'm going to go to negative 3, positive 4, because this maps across and we can connect those dots, okay? This means that analytically, this has the same property as f of negative x is the same as f of x, which means I can be symmetrical in the x direction and the y stay the same. So we can prove this by substituting in negative x and see if we get back to the same original function. So let's go ahead and try this. We're going to show analytically that f of x is an even function. So if I plug in negative x to test it, if it's an even function, when I plug this in, I should get back to the original function. So instead of x to the 6 minus 4x squared, we're going to plug in negative x. And let's clean this up. So negative x to the 6th power is negative x times negative x times negative x and all the times 6, right? 6 of itself, which is a positive x to the 6th. A negative x squared is just positive x squared times a negative 4 is negative 4x squared. So if I compare this now from here to here, they are the same. Therefore, the function is even. Okay, whereas an odd function is a little bit different. So it's graphically symmetric over the point 0, 0. Remember, it maps from x comma y to negative x negative y, right? So this point here, let's say here is 1 comma negative 2, would now, so if this is 1 comma negative 2, I'm going to flip it. It's going to become negative 1 positive 2. And that's what that's going to look like right there. If I look at this point here, it looks like it's about 2 comma, what is this, negative 1, 2, 3, 4, 5, 6, 7, 8.5. So that means I'm going to flip it over to negative 2 comma 8.5. Right here. That's going to look something like this. Okay. And then if I want to see where like this point is, that's at positive 2.5 comma 0, so we're going to switch it to negative 2.5 comma 0, and so on. Okay, and we can see that that looks pretty symmetrical over the origin. So if I input f of negative x and it's odd, I'm going to get out a negative of overall f of x. This is called the opposite. So let's prove this, okay? So if I'm substituting in negative x, we're going to see the opposite. function of the original function. So let's look at this. So if I want to see if f of x is odd, I'm going to input negative x. This is to test it, okay? So here we go, negative 2x to the third plus 5 times x. And instead of negative x, I'm going to plug it in, or instead of x, I'm going to plug in negative x. Here, I know negative x to the third is just negative x times a negative 2 is positive x to the third. And then 5 times negative x is negative 5x. Let's compare it. So this was negative, now this is positive. This was positive, now this is negative. Everything is opposite. So since it's opposite, we know this is an odd function. Okay. This last one, go ahead and try this on your own. All right, let's see if it works. So f of negative x, to test it, we get 6 times negative x to the fourth minus 2 times negative x. And we see that this is negative to the fourth power is just a positive, and negative times negative is a positive as well. If I compare these two, this is the same, but this is different. So they're neither the same nor opposite, so this is neither, because it's not the same or opposite. All right. And then lastly, shortcut for simple polynomial form. If a polynomial is simply one term, okay, then if the power is even, the function's even. If the power is odd, then the function is odd. So for example, this is one term. The power is odd, so therefore this is an odd function, no test needed. This is one term, this is an even function, therefore the function's even. This is an even power, therefore the function is even. No test needed because it's just one term. That's all for today. See you in class.